Hello, welcome to this video where we're going to go through an exercise for chapter 6 where we translate this expression over here into intermediate code. And this is for the textbook Introduction to Compiler Design. And for chapter 6, it's all about intermediate code generation. So by this point, you can imagine that you've already lexed your input and you've constructed your syntax tree, which is for this one over here. And for this question, you've been given the following details over here. New var, which is a function that returns a sequence of variables t1, t2, t3. This is going to be used for when you're generating a new variable for the language that you're uh, like for the language that you're translating into. And then you're given a description for a variable symbol table, which I've written down over here on this table. And you're also given a description for a function table that has been written over here. So a variable table just keeps track of all the variables that are there and the equivalent one in the translated language. And the grammar that this input is following, you've been given over here, which is this one. And so where do you start? So one way to visualize it, at least to give you an idea of what the structure for this would look like if you converted it into a syntax tree, it would look like this over here. You don't have to create a syntax tree to solve this problem, but it helps to visualize what you're doing. So the goal here is to write a function that will start at the root of the tree and make its way down. And for each branch, you'd have to execute code that can basically use this to generate new code. And the text in bold here is the terminals, or in other words, these are also the token classes, and the text in orange, those are the actual values. And you just have to write code that understands the structure and can basically help you generate new code. And how do you do that? How would that code look like? So for this grammar over here, you'll notice that the textbook has tables, and these tables are actually functions with cases over here. So for the last two rules over here, we have these two tables on how to basically analyze the structure for expressions. And the function to handle expressions is called trans expressions, which takes in a v table and an f table. And we also have expressions over here, and the code to handle the expression structure is over here. And the way this code is written is in a recursive manner, and so it recursively go down. Okay, so before I carry on, let me demonstrate how a new var works. It's actually quite simple. So I implemented one in JavaScript. So every time the function is called, you would get a new variable name. So you can imagine that the function would start with t. Let me just modify it a bit, where the function starts with t. Put it between the braces. You're going to put a t, so every time you call new var, you're going to get a whole new variable like so. And every time you call var, it always returns a unique variable name that we can use. So I think we can get started to solving the problem. So when we look at our tree, you'll notice that the first thing it is that it's an expressions over here. So that means the first function we're going to use is our expression function over here. Go. So our text over here, this expression, is going to match this entire expressions over here is going to match with this one over here because it's a single expression and we're not going to use the second one. So we're going to start executing this code over here. And I'm just going to paste our function. And this is the first function call that we're making, trans expressions. And we're going to pass in our v table, which has the information of the v table, and our f table. And that'll be the first function call. And what this function will do, the first line of code, is that we're going to have place, and place is going to be a new var. So the new var, we're going to say it's T0 for now. So that's going to be the first function call. And then the second line of code is code 1. And code 1 is going to equal to trans express. And we're going to pass in expression, which is the whole thing. So we're going to pass in that. And then we're going to put in our V table and our F table. And we have place, and we already know what the value of place is going to be. It's going to be T0. So I'm just going to expand it over here. So this will be our first function call. I'm just going to make it up. And then over here, we're just going to print out code 1, comma place. So this is what we're going to output. So now that in order to get these values, we know what place is going to be. Place is going to be T0. But now we have to get code 1. And to get code 1, we have to do a function call and for this one over here. So for this, we're just going to do this. And now we have this very first function call, this second function call over here, which is going to be for T0. And this will come from this function over here. So we're going to look at our expression table. So on our expression table, we notice that this whole expression is going to match with the binary operator one. It won't match with the ID one. It won't match with the unary operator one. And it won't match with ID. It's going to match with this one. I do mind the doodles over here. It was from the previous session. And now we're going to put place 1 and we're going to set it equal to new var. And new var is going to be T1. And then place 2 is going to equal to T2. So I'm just following the code for this one. I'm just following the code from here, in case you're wondering. And then I'm gonna make code 1, and code 1 is going to equal to trans expression, where we have xp1. So what is xp1? Since we're breaking up this one over here, we're gonna say xp1 is going to be 3, and our binary operator is going to be the plus, and our function is going to be f over here, which takes in these variables. So instead of expression 1, we're just going to pass in 3, and we're also going to pass in our v table, and then we're going to pass in our f table, and over here, which is blocking, we're going to put in place 1, and we already generated the value for place 1, which is going to be t1. And then we make video 2, code 2, which is going to equals to trans express, and this is going to take in f x minus 1 comma z. And then the second value is going to be v table, and we're going to pass in f table, and then we're going to pass in that t2. Then we have our operation, and the operation, this is a function called trans op, and get op name and binop, and our binop over here is just going to be the plus sign, and this is going to just be the plus sign for now. If it was another language, we could have get the equivalent for the plus sign, like add, or maybe in this language adding is 0 0 or something like that, but in our case it's just going to be 1. Now we have code 1 plus plus code 1 plus plus code 2 plus plus, and then we have place, and we know what place is. The place is this variable over here, the one that we passed in. So it's going to be T0 equals to place 1. What is place 1? It's going to be T1. What's our operator? Plus then T2. Correct. And we don't have code 1 yet. And these plus plus is basically concatenation of strings. So the output for this one would be, let me move this down so that you know where this came from over here. So this is for code 1, just a reminder. So this is all for code 1. This code 1 over here, since it's a recursive call. So it's going to be there. And this will return. So the plus plus basically stands for concatenation. And to get the full thing, we have to get our code 2 and our code 1. And that means you have to compute this function, and you also have to compute that function as well. And let's get to it. So we're gonna branch out twice, where we're basically going to solve for this one over here, and then we're gonna make another function call where we're gonna make it a text where we're just going to get for this as well. So we'll figure this part out later, and this part. And to make it easy, I'm just gonna put in code 1 so that we know this is for code 1 and this is for code 2. And now let's start solving. So since we're passing this into trans expression, we're still going to reuse this function over here. And since we're passing in 3 and it's a number, we're going to match it with this first case over here. And so how would that work? It's going to be v, and it's going to be v get value. Oh my god, that's not how you spell value. Then we're going to pass in our num, and our num is going to be 3. And then we're going to return. So I forgot to mention that the last line of each instruction is the return value. So place is going to be t1 equaling to 3. So this is what's going to be returned in our function. So when we go back over here, t1, code 1 is just going to equal to t1 equals to 3. And hopefully that made sense. And now we're going to do the same with this one over here. Now we're executing this one. So this whole thing is going into trans expression. So we're using this one over here. So to find it, we're going to match it with the one at the bottom, because it's the one that makes sense, where our ID is going to be F and our expressions is going to be this one over here. So how does this work? So the first thing we're doing, so that it's going to say this, and then it's going to say code 1, comma, dash, A1, comma, dot, and AN. And all of this is going to equal to trans expressions. So to keep in mind, this is expressions. So that means we're going to use another function to get this. And also notice that we're using a tuple, where basically we're going to get 2 values as an output from this trans expression. So do keep in mind that each one of these functions has a structure, a return type. So this trans expression is going to return a tuple. You'll see what I mean later. Oh, oopsie. Okay, and what do we pass into our trans expressions? We're going to pass in, since we know our f, we're going to pass in expressions, which is going to be x minus y comma z. And now we're going to pass in v table, and we're going to pass in f table. And that's the first line. And then over here, we're going to get f name equals to lookup, and then f table. And then we're going to say get name, and then we're going to pass in f. And how does this line of code work? So since we're looking up, so this is a lookup, an example of a lookup, where we get the name of our function f, and then we're going to look it up on our f table. And remember that in our f table, we said that our function table that keeps track of the variable names is that a function table that binds f to underscore f. So that means we're going to have to replace our f. In this translated language, f will just be underscore f. And we're going to put it over here as our output. So we're just going to get underscore f, or we can just put it like this, underscore f. Put it in a string or anything, it really doesn't, as long as the ID is there. And now that we have f name, what else is there? So we're going to get our code 1 and then plus plus, and then it's going to be this, and then it's going to be place. And what is our place? It's going to be t2, and t2 equals to call, and our function name f, and then everything in between a1, a2, and an. And where do we get that? I think we get it from here. So all of our expressions will get it over here. So whatever, once we calculate this, because all of these over here is what we're going to be passing, and this will be returned by this function. So let's do this function call, and then we'll get our result, and also code 1. So that means I have to create another function. So I'm just going to copy this, and I'm just going to branch off again. It's going to be text. So now we're doing this one, which is for code 1. So code 1, this is for expressions. And remember, so we're not going to use this function because it's just for a single expression. So you want this one, which is for our whole expressions. So now we have to do some matching. So which one does this match with the most? So this is going to match with the second one because all of this matches with this. It's 2 expressions rather than 1. So to evaluate this, we're going to say place equals to new var. And what is our new var? In this case, I forgot what the latest one was called. The last time we did new var, we got, let's see, hopefully I'll edit this part out where I'm looking for the new variable, new var. So this is get value, then pass in t1. Okay, t2, I believe it's going to be t3 now. There you go. And yeah, so we got our place, which is going to be t3. And then we have to find code 1 and equals to trans expression. And what is our expression over here? The first expression is going to be x minus y, then comma what, comma our v table, and then f table. Okay. And then we're going to do code 2, which equals to, and then we get our args, or arguments, and then trans expressions. And then just going to move it like so. Trans expressions, we're going to pass in our expressions, which is just the letter z. And then we're going to pass in our v table, and then our f table. And what else do we have? So again, remember that there's a tuple again. So we're going to have code 3 equals to code 1 plus plus and code 2. We don't have code 1 or code 2, but we'll get to them later. Then our args will equal to place, colon, args. So this operator, colon, is basically appending 2 arrays. So you're combining 2 arrays. So this is an example like if we had an array 1 and 2, and then we had 3 and 4, and we put like the 2 spaces in between, the result would be 1, 2, 3, 4. So that's the colon operator. So it's just going to take whatever array this is and combine it. And then we're going to have code 3 and args 1. And yeah, let's go get it. Let's start with this one, where let's branch out, where we're trying to get code 1. We're trying to get code 1. So we'll name this code 1. And then we're also trying to get this one as well. And pass this in. Leave 3 dots. We'll get to that. This one will just be for code 2. And we'll see how it goes. So we're just going to do this one and see how it goes. So this one, since it's for trans expression, that means we're going to refer to this function over here. And we're going to try that. So this one is going to match with our binary operator over here. So since our binary operator is over here, what we're going to do is place 1 is going to equal to new var. And what is new var? New var is going to be our t3, not t4, since we already used it. Then place 2 is also going to be a new var. So we're just going to name this whole thing t5. And then what else? Operator. So operator is going to equal to trans op, and get op name. So this is going to be bind up, and our bind operation is going to be minus. In this case, remember, it could be anything, but we're just going to use minus. In this case, in the case of the textbook, this always returns the same operator. So in the language we're translating to, minus is minus. Now, do you know? Okay, I feel like, yep, I skipped a whole block. I skipped the whole block. I think it should be better if I had it over here so that I can see it better. So this is going to be code 1, and code 1 is going to equal to trans, and then it's going to be exp1, and what is exp1? exp1 is going to be x. It's going to be x, and then we're going to pass in our v table, and then our f table, and then our t4. And then our code 2 is going to equal to trans expression, and then it's going to be y, and then it's going to be our v table, it's going to be our f table, then it's going to be t5. And then what do we get here? So we're going to get code 1 plus plus plus, so it is what we're going to be returning, plus plus plus, equaling to code 2 plus plus plus, and place 1. So what is place? Place, I forgot to put in a place. I forgot to put in a place over here. Let's see. Yep. So when we're calling code 1, forgot to put in a place, so we calculated the place, which is T3. Yes. So over here, the place is supposed to be here. Okay. So it's supposed to be T3. And the place that we're going to be putting in is going to be T3. And then it's going to be equaling to, not G3, T3. Place we're going to be putting into is place 1, which is T4 minus T5. And then we just have to get code 1 and code 2, which should be fairly easy. Okay, so I'm just going to copy this, and I'll just put over here, make sure that we're actually paused in a place this time. We did, and we're going to do this. Now, we'll get to this later, and this is for code 1. And now we're going to do the same thing, where we basically take this, and we're just going to hit code 2. And it's just going to be our code 2. And yeah, let's start with this one. Since we're doing x, we're going to go over here. We're going to look at our table. I'm just going to shift it to over here so that we can look at it side by side. Since we're passing in x, which is a variable, we're going to make use of our v table. And let me just go grab our v table all the way from here. It's quite long, so you can tell that recursion is always something. So make sure you have a good mental model. So make sure you practice this so that you have an understanding how to do it properly, so that you don't mess up. But yeah, recursion is something. So it's gonna match with this. So since it's another lookup, what we're gonna do is that our x is going to equal to our lookup. And in our v table, x will be mapped with v0. So our lookup at our v table for get name ID or x is going to give us v0. And now we're gonna return place equals to x, where our x is v0 and our place is going to be t4. So this is what's being returned. So now it's gonna be t4. I can put it in a string because that's what we're returning at the end. Just gonna move it a bit like this. Equal to v0, and over here is gonna equal to. So now we have to get this one. So you can imagine we're gonna follow the same process where we pass in a y. We do y lookup v table I messed up again. Over here, there we go. It's going to be get name y. And our y, we said, is going to be, at least the v table, is going to be v1. And hence we're going to return place equal to x, where our x is v1 and our place is t5. Now we're just going to return this whole thing over here and put it in the string. There we go. And we got this over here. And now that we return this, we're basically going to return, so this is actually the first one where we actually completed the whole function, which is a big yay, at least like in terms of this one. But so that means the code that we return is going to be this string over here, plus. So the plus stands for concatenation. So it's just going to be this. And you can even write it like so to make it easy. Just create a new line. Yeah, so this is basically what we're returning. We're returning this whole thing. Oh yeah. So now we have code 1. So we're just gonna put in our code 1 over here. So our code 1 will basically equal to all of this. And we're just gonna put it in color so that we can recognize, because we're gonna have to. Is this a good color? Let's choose this one. There we go, because it pops. And now we're gonna pass in. Now we're gonna do this function over here, and so now we have to go get code 2. So to get code 2, we pass into trans expressions. So we're gonna make use of this one. And the way that works is that we're gonna have to create a new variable. So we're gonna have place equals to new var, and our new var is going to equal to t6. I hope t6 is free. Hopefully that's it. As long as it's unique. So it's t6, and then what do we have here? What do you have? Okay, we're gonna have code 1. It's gonna be trans expression, to which we pass in our letter z, and it's gonna be v table, and it's gonna be f table, and it's gonna be t6 that's being passed in. And we're gonna need this for later. So now, and when we get our code 1, we're going to return code 1, and we're also going to return place. And what is our place? It's gonna be t6. Okay, so we're just gonna pass this in here, and it's going to be this. And yeah, there you go. And we basically, since it's a tens, we're gonna make use of this table over here. And since it's an ID, we're gonna say x equals to lookup and v table on our variable table. We're gonna get the name of ID, and ID is gonna be z. And what is our z? We look at our table over here. Z gets mapped to v2, so you're gonna say v2. And once you have v2, not v2 anymore, that's basically what we're gonna return. So we're gonna return place x. And what is place? Place is going to be t6, because again, place t6 over here. And now our x is going to be v2. So this is what we're returning. So this is the code that we're returning. Now, this was our code 1. So now our code 1 equals to this whole string, equals to this whole thing, and then we can replace this. And this is what we're returning to this over here. So our code 2 is going to return the whole of this. It's going to return the whole of this over here. Yeah, I think that's done correctly. And now we're gonna concatenate the two functions. So we're gonna concatenate code 1 and code 2. So that means code 1 and code 2 are gonna become 1. So I already have our code 1 from over here. And we just have to combine it with code 2 over here. Oh my. This is code 2, which is this one. Oh my, what did I do? Okay, there you go. And then we're gonna have args over here. Where did we get args? Right. Okay. Oh yeah, the args was basically this. Our args was basically just T6. And then what's our place? It's T3. T3. So that means our result here is just going to be T3, comma T6. And we're just going to return this and our code 3, which is this whole thing over here. And yeah, hopefully this is making sense. And then we're returning all of this, which was requested by this one over here. Over here. I feel like we're supposed to do something over here. Oh yeah. This is all correct. This is all correct. So now we have this, our tuple. So all of this equals to all of this. All right. So that means we're going to copy, because if you can see, it's all like a single thing. We can, oh my, hopefully, yeah, we did not lose this, because imagine, I don't know how long I've been recording for, but yeah, it would not be good to lose this. So we're going to take this string over here and combine it with this string over here to give us this. So it's a plus 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 thing going on. So we can just make it all into one thing like that. And this whole expression will be returned to over here. So now we have T1, and then we have T2, which equals to this. We combine them both. So over here, this is where we needed T1. So we're just gonna take it over here. This is our T1. Concat. And yeah. I'm just gonna copy all of this and paste it over here. And yeah, and this as well. And yeah, that's the code. And this one gets returned over here. Like I made a whoopsie. Did I make a whoopsie? No, I did not. So over here will just equals to this. And the return would be all of this then. And the final result, the output, finally, after so long, this is the result. Where we have all of this. There you go. And is it the, so hopefully getting this made sense. The most important thing is being able to check whether it's correct or not. So this question, you can find it in the test book over here. It's one of the examples. This one, is it the same thing? I hope so. We can just cut over here. Yeah, it looks like it. So that's how you get that result. We're missing a piece over here that I'm a bit too lazy to figure out what went wrong, because we got T1. We're missing our T2 or T4. Did we get a T4 somewhere down there? 1, 2, 3, 4, 5, 6, 7, 2, 3. Yeah, I forgot a T4 somewhere. Looks like I forgot to copy a T4 at some point, but hopefully you'll be able to find it. That will be like a surprise quiz for you. But yeah, that's how you do it. Thank you very much for sticking this long. And yeah, thank you.